Hi, I am Cinthya Aguilar Diaz. I'm from Team 401. I'm going to explain my integrating project, that is the production of rubber hoses with good quality and no money lost. The introduction. These uh, rubber hoses are going to be made, but these must have a good quality and we must not have the money lost. And with all the subjects, I'm going to analyze the situation, and I'm going to apply my knowledge acquired to find to choose the correct solution. The case statement, well, as I said, in this manufacturing processes, different types of rubber hoses will be made. And it's important to say that this is a new company, so that's why we don't have money lost, because we don't have like the capital. So the proposal of possible solution is that there are two alternatives: to buy a high quality and no flanked extruder, or to propose a methodology that determines critical variables in the manufacturing process of a hose. And these are all the subjects, sorry, that are going to be applied. Now, the analysis and argumentation of the results. And in this time, special manufacturing processes with the teacher Marcela Noemi Ibarra Castro. And there are different ways to do the houses, and but as we want to do small diameters, it's better to choose the extrusion. Spiral wrapping is for larger diameters. The extrusion, this is the diagram of the extrusion, and this is a continuous process. This is the equipment of all the extruder, all the feed hopper, plastic pellets, and all the pellets are put in the hopper, and the turning screw makes the pellets to flow into the barrel, and the heaters will heat the plastic, and the shaping die is going to give the shape of the final product. The materials that are going to be used are pellets of different or high and low density polyethylene, polypropylene, polyurethane, and all those kinds of polymers. And the parameters that must be controlled are these: any action that can stabilize any parameter or condition is beneficial to the process. It's so important to have a control of all these parameters. And the product design considerations, is important to say that there are two types of designs, two types of hoses, sorry, the one design and the more than one design. And it's important to say this because there are different considerations from one to another. So this is the inspection of the raw material. Everything must be inspected and controlled. The resin density, the melt index, and all those. The resin storage is important because it must be in a clean and a dry area. The gravimetric resin feeding. This time we're going to use the float feeding, that is by gravity, because it is used from rubbers from one layer or from one resin. The star feeding is used for multi-layer products, and the feeder controls the flow of the pellets. These are the parameters to choose an extruder. All these rectangles, these must be analyzed in order to choose the correct extruder. And as you can see here, the instrument calibration is very important, because if we don't have a calibration, we cannot trust in the information that is given it. So this is the air gap and question try. The air gap is when the final product, goes out from the extruder, and there is sometimes there is a air gap, and you can see here in this case the rubber, and then it tries in a quench, in a quenching where the water is the media where the host transfer the heat. Sometimes it's just nitrogen, but it's to do it more quickly. These are the product measurements instruments are very important because here we can control the quality of of the of the rubber. Here it's important to, well, it's better to use a dual axis laser because here you can see that it measures it measures better than a normal laser measurement. The product cutoff, it can use by a winder or cutting products. The cold extruder thruster. Here, this is the new this is the option of the extruder that I said before, that to buy a new extruder. This is the extruder, the thruster. Here are the benefits of this extruder. So here I think, yes, here finishes this part of the subject and starts with project administration by the teacher young Jorge Tienda Miranda. And the starting and selecting the project. Here there are two options to buy a high quality and new flanged extruder. And the project B propose a methodology that determines critical variables in the manufacturing process of a hose. Here is information first of the project A. The cost of the thruster extruder is this: 6,795,266.40 Mexican pesos. It's a lot. And project A requires, it requires that quantity of money of investment with the flow operating cash expected of 800,000 annually for 5 years. So having in account this information and also this information that the opportunity rate in Mexico is between 5 to 10%. As you can see in the map, there are different opportunity rates in different countries. There is a calculation, and it's necessary to calculate the net present value and the internal rate of return. And as you can see in the calculation, the NPV is negative and the ERR is negative. So that's a very bad project because it exceeds the present value of the revenues, and this project must be rejected. Now, the comparison of the attributes. Does the project increase the profitability? There is a comparison of the attributes of these two projects. This main, as shown in the table. Project A only has 10 out of 100 of score. It's a very bad project. But the project B has 100 out of 100. Project B is the most rentable, so this is the project that is going to be taken. Now, the general objective is a proposed methodology that determines the critical variables in the manufacturing process of a hose. The specific objectives establish necessary equipments in the manufacturing of a hose. Well, there are the specific objectives to know specifically what is going to be made, and the limitation is the actual extruder that we have. So the project team will be divided in production, quality, and maintenance. So here are the parameters that are going to be evaluated. And these are the stages that are going to be followed. The corrective actions are these. The non-uniform color, well, these are going to be controlled by these departments: quality, maintenance, and production. Here it says the activities that they must do, and here is like a manual of the extruder for operators, and this is the requirements that the people that work in these departments must have. this is the organizational structure of the company. And now we're going to start with operation research. Here is a problem that there are two kinds of hosts that are going to be made, and in this time we are going to calculate the maximum sale. So taking into account all this data, I put it in a table and I do the constraints, and I did a simplex method. And as you can see there, x1 equals 5,000, x2 333.3, and c is 2,250,200. Well, that quantity of money is going to be the maximum sale. So in order to make sure that these calculations are correct, I put this data in the constraints, the limitants, and it met the comparisons. So the maximum sale will be the 2,250,000 pesos. It's going to be the maximum sale, selling the 500 100 houses of this type, and the 8,333.3 selling this house. This is the quantity of houses that must be sold in order to have the maximum sale. The feasible space method is the same, so I just did in another way. I put it in a table, and as you can see here, this is the feasible area of the first constraint. That are these areas that is the shown. This area is the one that is shown with the arrows, and I did the same with the another constraint, and this is the feasible space from this constraint, and this is the critical path method. So you can see here all this critical. I did the critical path method. This was done with the activities that were made in order to choose the correct project. This is the critical path method. Well, these are the activities that were used to do the critical path method. There is a lot of critical paths, so any activity cannot be changed in time. This is the Gantt diagram. This is the mechatronics. I did a PLC programming that will that controls the temperatures with a PID, and here are shown that here are the resin types that are going to be controlled are the ones that are shown, that CN, LLDPE, MLLDPE. All these resins are going to be controlled, and each one has different temperatures. So here the plastomer, where if you choose specifically one type of resin, this PLC will control the temperatures. If it is too low, if it is too high, it will control it. Each one has it, and it is controlled by a PID controller. Here are shown the inputs and the outputs. The inputs are the zone one, because as you can see here, there are 5 zones. These 5 zones must be controlled. So the maximal and the minimal zone of each one is controlled by the inputs, and the outputs, well, is the the resistance heating at the temperature. And it's important to say that these are controlled by the PID. This PID is is better is better configured in a different way than a ladder diagram, because it is easier. And as you can see here, well, the PID will be given the interest to the PLC. As you can see here, if it is too high or it is too low, the PID will control it. And the same for manufacturing and assembly. Here, as you can see here, there are different considerations for a conical mandrel with a spiral roof. And design for fewer components in the forming head, use fewer large bolts or other fasteners, design the head assembly so that it's easy to handle when hot, and the internal volume of the head needs to be balanced with the shear rates of produced with the head. And lower volume is preferred, but lower volume also increases internal shear rates. Increased volumes allow increased melt equilibrium, and lower shear rates at the cost of thermal history and potential degradation. Critical shear rates for polymers at various temperatures are usually available through polymer manufacturers. These are the considerations for making the ones that gives the the shape of the final product. These are the examples of DPA applied in real cases. Here are two different kinds of this part of the extruder. You can read the considerations that were taken in order to do these parts of the extruder. So now, finally, the discrete event simulation with the teacher Jose de Jesus Ramirez Mendez. It's important to now that we supposed to have supposed to have reached the main goal. We have to see if that works. But after running this process, it's important to do simulation. So here, the binomial distribution, the binomial distribution, the Poisson probability, and the gravimetric distribution will be used. And first, the binomial distribution formula in the following. So this is the formula that I'm going to use. The project. The process, sorry. The process says that 3% of the houses are rejected. What is the probability that a batch of 20 houses will contain no more to reject? Well, first, the data is recognized in the formula. 20 houses, x is 0, 1, 2, y 0, 1, 2, because the probability of have 0, the probability of have 1, the probability of have 2, the probability of success, that is 0.03 here. The success is the failure, because we are looking for the failure. And the failure percentage is the 97. So you put this data on in the formula, and you can see here that, well, and the problem says no more than 2 rejects. The probability of not having any reject plus the probability of having 1 reject plus the probability of have 2 rejects. 0, 1, 2 are added. So we have the probability that there is 97.88% of having no more than 2 rejects, and that is excellent. That means that we have a very good process. And the probability of have at least 2 rejects. Here, the probability of have 0 rejects and the probability of have 1 reject is added, 79.26%. The Poisson probability. Now we're going to use this formula, and this is used when we have the main when we have the mean number of successes in a given time interval region. In this time, there was found that we have in the process there we have 3 problems every 3 weeks. So first, the probability is, well, the mean number is calculated, and then is done the calculations. Here, we are looking for no more than 1 failure. So the probability of 0 and probability of 1 are added, and it gives 98.83%, and that is excellent. And the geometric distribution, and where here we only have two data, that is the independent trial probability of success of number of trials before a success. We are taking in account that we have 3% of the effective rate. So I did it this time in Excel. So the number, what is the probability that the effective occurs in the first, second, third, fourth, fifth, sixth, seventh, eighth, and ninth and 10th host expected. Instead doing the calculation from each one, I did it in Excel, and you can see here the graphic. So in conclusion, the probability of having a defect in the host decreases as the number of taking houses increases. So the houses have a very good quality. So that means that we reached the main goal of this project. Here is a bibliography that I used, and that will be all. Thank you for have taught me these subjects.